Hi, gang. Meteorologist Dave Aguilera from CBS 4. I know that the third grade has been studying about the GOESR satellite, and we are out here at Cape Canaveral, Florida, getting ready for the launch this afternoon. With me running the camera back there is Mark Nitro. He's one of our great photographers at CBS 4. So joining me out here is Tim Gasparini. He's a program manager at Lockheed Martin, so he was an integral part of getting GOESR ready and getting it ready for launch. Hi, Tim. How you doing?
Dave, how are you? Good.
I'm doing fine. Thanks for joining us here.
Glad to be here.
Now, we're talking to third graders and whoever else wants to watch out there, but they've been studying it. So they sent us a few questions for you.
All right.
Hope you can answer these.
I hope I can too.
Okay, so here we go. There's a few of them. First off, and this one's a cool one. How fast does the rocket have to go to leave the Earth's atmosphere? And that was from Ethan. He sent that question in.
All right. Well, Ethan, we have to get the spacecraft and the rocket going 25,000 miles an hour. So faster than 25,000 miles an hour to leave the Earth's atmosphere.
That is fast.
That is fast.
Okay, the second one. This is from Gisani, and it's how much does the GOESR satellite weigh?
The GOESR spacecraft weighs 11,455 pounds. Okay. That's with all of the fuel on it.
Wow, okay, that's
pretty big.
Yeah. Now, what makes launching a satellite into space so difficult? This is from Desiree.
Well, Desiree, gravity for one. We have to overcome gravity, so it takes a lot of fuel and a lot of energy to push the satellite up into space. But then once it's up into space, it's all of the computations and all the math and the science that goes into making sure that the mission gets accomplished once it's up there.
Beautiful, beautiful. The next question is from Stella, and this is what you've been doing for years, right? What type of research goes into building a satellite like this?
Well, there's a lot of research, a lot of the special research goes into building the instruments. For example, we have what we call the geostationary lightning mapper that's on the spacecraft. It's the first time this has ever been flown in geostationary orbit. And there's been a lot of research gone into figuring out how to look at lightning, especially during the daytime from space, and then making a connection between lightning and when storms come. So there's been a lot of research that's gone into that. It's just one area, one small area of where they've done it on the spacecraft.
Wow. I thought what was interesting, too, was all the information from, like, the solar mapper and the magnetometer and all that might help us when we get interference with like GPS.
The space
and
weather?
like that. Yeah.
Yeah, so, not only, we talk a lot about weather on Earth, and Dave talks a lot about weather on Earth, but there's also weather in space. The sun sends charged particles and energy to the Earth that can disrupt our communications. It can disrupt the GPS on people's phones or in airplanes as they're trying to fly. It can even disrupt the power on Earth. And so there's instruments on the spacecraft, and they've done research to develop these instruments to help us understand when that space weather and how intense it is gets to the Earth.
So we're going to be able to study weather on Earth and essentially weather in space as well, right?
With one satellite.
This is huge. This is huge. Okay, our next question is from Nieli, and she asks, how do you get the satellite into the rocket to shoot it into space?
Well, the way that they do that is they, before the nose of the rocket comes actually in two halves. And so what they do is they put the rocket on what they call the payload adapter fitting, which is a big piece of the top of the rocket. And then they bring the two halves of the nose cone together. And then they lift that whole thing up and move it out to the launch pad and then lift it up and put it on the top of the rocket.
Beautiful. Lily W. asks, how far out does the GOESR satellite orbit the Earth?
Well, so the GOESR satellite is at a place they call geostationary orbit. And what that means is that the spacecraft is always over the same spot of the Earth. And that is about 22,000 miles from the Earth.
All right. Lydia has her next question, and her question is, what materials is the satellite mostly made of?
Well, the spacecraft is made up of all different kinds of materials. There's aluminum, there's steel, there's titanium for metals, But we also use what's called composite materials, which are carbon fiber and epoxies or glues for some parts of the spacecraft. And those are the parts we use for the structure to make it very lightweight so we can send it into orbit.
Okay, Nicholas has our next question. How is the GOESR satellite powered once it's in space?
Well, Nicholas, the GOESR spacecraft has very big solar arrays. So it has solar arrays that are 10 meters long, or about 30 feet long. Not quite 30 feet long, that are on the spacecraft to give it power once it's in space.
Beautiful. And this one from Bryant. When sending information, does the satellite really send out ones and zeros back to Earth?
You know, it really does. It really sends ones and zeros back to Earth, and then when it gets to the Earth, they're decoded. When they send it down to the Earth, sometimes they worry about losing information. And so that information is encoded in a very special way so that when it gets down to the Earth, they can decode it and make sure that they didn't lose any of those ones or zeros.
That's almost the most surprising thing, I think, to most people, that that's how the information comes down.
Yeah,
Ones and zeros.
it does. It comes down to ones and zeros.
Okay, last clip question, certainly last but not least. This is from Mr. Sherlock. Is that one of the students, or is that?
That's one of the teachers. Yeah,
he's the teacher.
He's the
Mr.
teacher.
Sherlock. Okay. How do you know what day is the best to launch a rocket?
Well, you know, it depends on where you want to go. And so they define where they want to go in orbit, and then they kind of back figure when the spacecraft launches on what time of day it launches. And so it's simply a matter of where you want to go.
Which, to figure that out, you have to know.
You have to know math, you have to know science, geometry, physics. There's a lot of things that go into determining orbits, and you know, some of the orbit determination guys are some of the smartest guys there are figuring all that out.
All right, so our third graders, you need to study math, science, geography, physics,
That's right.
all of that. And English too, right? Because you got to communicate everything, right?
You know, and sometimes there's been very smart engineers that have had a hard time communicating, and the things that they wanted to communicate where they weren't able to.
So maybe some of our third graders will be future engineers and scientists that work on
Perhaps,
future
that'd be
launches.
great.
And this was a twofold question, but since I do the weather, we got to talk about the weather. Today's beautiful down there. We got sunshine, a little breeze blowing, and it's going to be a pretty nice for lunch. The other question Mr. Sherlock had is, what are the conditions you are looking for when you launch?
When we launch, they're looking for, they don't want to have a lot of clouds because certain kind of clouds cause lightning, and they don't want the lightning to hit the launch vehicle as it goes up. And they certainly don't want high winds. They have a criteria on the rocket that if the winds are above a certain value, they won't launch the rocket because it'll be too powerful to launch the rocket, and the rocket might not be able to do what it needs to do.
Beautiful.
So
Tim?
winds
Got maybe some more questions from people, but
Yeah, are there questions
there is
out
actually a question from somebody, Julie. I wanted to know more about today's launch window and if that was still kind of on track and what was going on kind of like coming up here in the next couple hours.
Okay.
It is. The launch window opens at 5:42 Eastern Time. So if you guys are in Colorado, that's 3:42. And it's open for 1 hour. So from 3:42 your time to 4:42 your time. And as Dave said, the weather's beautiful and the rocket's good and the spacecraft is healthy. So they're getting ready to go.
Good deal. Good deal.
Any other GOESR questions? I know somebody has a question about something else from Milwaukee, but
Yeah.
I think we're going to stick with GOESR today.
Okay,
I
yeah,
think
let's
so.
stick with GOESR. With that. You know, one thing, and if any of you have been following us with our reports here, and if you haven't, you may not know this, but there's a huge Colorado connection with GOESR. That's kind of the reason we're down here covering it. Can we talk a little bit about that? Who's involved back in Colorado that
We
put
can.
everything together?
Sure. Well, there's, I guess I'll start with Lockheed Martin since that's what I work for.
Yeah, sure.
We built the spacecraft, and we actually built two of the instruments that are on the spacecraft. CU LASP builds one of the instruments that's on the spacecraft. And we have a number of other subcontractors in the area, in the Denver metro area, that have also worked on the spacecraft. So there's been a lot of effort in Colorado.
Beautiful. So hard to believe that, because the launches usually occur like in Florida and along the coast, but Colorado back up in the mountains has a huge impact on the space.
And you guys are forgetting one thing too, ULA.
Oh, yeah,
And
ULA.
And ULA is also in Colorado, who builds a rocket, yes.
Yeah, and ULA is, for those that don't know,
United Launch Alliance. So they build the Atlas.
which is like a combination of
Boeing
Lockheed
and
Boeing.
Lockheed Martin, they are, build the launch vehicles for the United States, for NOAA and NASA.
So you guys get along, you're right?
Yes, we do.
I thought there was an interesting fact today too that we talked about was the Atlas V and how it actually lifts off from the pad.
Oh, yeah.
That's kind of a
Gary
neat.
Napier was telling us that when the rocket takes off, a lot of rockets just go real slow and lumber, but this is going to
This
almost
one's
jump,
going to jump
right?
off the pad because the